What's up, YouTubers? So for today, we are finishing up part 3 of the dual shield 035 flux core wire that I've been testing in the previous 2 videos. So we're going to do an actual break test, and I'm going to give, I guess, my final opinion on the validity of this particular wire and the process on 200 amp or less machines. So let's get into it. Alright, so I did 3 welds with this dual shield flux core. The one on the right was done at lower voltage, decent wire feed, and then both of these were done with higher voltage. And that's to kind of get a feel for whether or not higher settings will give us better performance, which in the case of this, I think it will. But if you watch the previous test I did, there was poor penetration on 1/4 inch, pretty much no matter what my settings were. And this is even thicker, so I don't have high expectations. All of the welds look very much the same despite being run with different settings. This at 26 volt and 25 volts kind of nipped the edge of the plate off a little bit. There wasn't a lot I could do about that, unfortunately. And it's funny because to me it looks like it's running plenty hot, but man, there's no root fusion according to the previous videos, so pretty interesting. Weld defect wise, there's a little bit of a worm track right there. I'm not too worried about that. I mean, it's at the surface, probably isn't going to make a difference. Maybe my stick out was a little too close, who knows on that. But I guess so far, I'm kind of hoping that the test results of this are decent. And the reason I say that is because, well, for one, I bought 50 pounds of this stuff, or excuse me, 10 pounds, 50 bucks worth. And if it can't weld 1/4 inch thick steel with decent penetration and decent performance, well, you know, I guess it's not really worth much to me. And two, I kind of was hoping that this would solve a lot of the issues that flux core wire has, which flux core wire on thicker steel like 1/4 inch, and it really shouldn't be used for 3/8 with 200 amp MIG welder, but it has a tendency to produce a high amount of porosity on thicker steel, likely because that weld pool quenches and the gas that's created from the flux can't escape from it in time. So this dual shield so far has clean welds. I mean, they look good, visually appealing, and there's no internal porosity I've seen so far, but there's also no penetration. So I don't know, so far, you know, I don't know what to think of this stuff. We'll see where it bend tests out at and compare it to MIG and flux core and stick, and kind of give an opinion on where we're at, I guess. And at the end of this video, like I said earlier, I'll give a general overview of what I think of this. So without anything further said, let's go chuck it in a vise and bend it. Alright, so first up we have the one that was run at 25 volts, 410 inches per minute. This seemed to be kind of like, I don't know, globular to spray transfer. It definitely, the wire was not hitting that puddle. It was liquid before it hit it. There's a little bit of, I don't know, not BBs, but balls at the end, so it's more or less globular transfer, I would say. A little bit more voltage, it definitely would have been spray. But like I said, 25 volts, 410 inches a minute. Let's see what it takes to break it. All right, let's go. $86. Not too bad of a result. Let's go to the next one. I'll reset that. So for this guy, this was run at 26 volts, 390 inches per minute. This, I would say, definitely from what I saw would qualify for spray. The wire was completely, like, it just sprayed in there. It had almost no sound. It just hissed, no spatter. The wire feed was almost on the low end. Like, I could almost see it starting to burn back close to the tip, but definitely a lot of voltage. So like I said, 26 volt, 390 inches per minute. Let's brake test it. 66.7. So a little bit lower of result on that, and when I fully break them, we'll be able to look on the backside and get a feel for what happened. Now this last one was run at 23 volts and 350 inches per minute, so much lower wire feed, much lower voltage. This was a setting I saw online that someone claimed to use to weld 3/8 plate and 1/4 inch, which I don't honestly think this is going to perform well at all, but I guess we'll find out, won't we? All right, let's break it. And 74.8. All right, well, let's go back to the table and look at what we got. So let's take a look. We'll start with the one that was run at 25 volts, 410 inches per minute. When we take a look at it, the weld broke right down the middle, just like we would like. We don't want to see it detach from either plate due to lack of fusion. The weld structure itself is very clean. Like, I don't see any evidence anywhere in here of porosity, even at the start, so that's good. The problem is, if you look here, and let me zoom in for you, look how the original edge of that plate is completely intact. Essentially, the root of this joint was completely bridged over with no fusion. Even short arc MIG and flux core had more penetration than this, so that is not good at all, and all of them are like that. But in this close-up, you can see, I mean, the weld looks clean. No real issue there. From the surface, it would look like it was plenty hot to have some sort of fusion, but just like the 1/4 inch plate, no root fusion. And this really reminds me of 7014, and I'll put a picture of 7014 up, where it makes good penetration into the sides, but for whatever unknown reason, it has zero root fusion. Well, this stuff, same deal there. And when we look at this guy, and I'll bring it over, this was run with 26 volts, 390, so a little bit more voltage, a little bit less wire feed, same deal. Zero root fusion, nothing in there. The end here, it kind of melted off just because, well, there was no heatsink anymore, but no fusion, same clean weld, broke down the face of it right in the middle, which is exactly what you would want to see here rather than pulling off the plate. No root fusion, and I think that's why these did not have the strength that they really should have, considering how big this weld actually is. I mean, this is bigger than the 7018 weld. It's on par with the MIG weld for size, yet much lower numbers for performance in the short arc MIG, which is kind of surprising, to be honest. Again, look at this. This is even worse. This whole thing right here literally had no fusion. Again, whole plate, original plate edge. So again, same as a 1/4 inch plate. Now the lower settings, 23 volt, this I kind of didn't expect to perform very well, and it didn't. But what I find interesting is I read a thing online of a guy using 035 dual shield, and he said these were the settings. 23 volt 350 is what he used for it, and clearly I would definitely not use that on this 1/4 inch or 3/8 plate. The other interesting thing is that I amp clamp metered the output of the welder on all of these. The setting of 23 volt and 350 inches per minute put this at 160 amps. So this is 160 amps of output. The highest, which was the 410-25, that was at exactly 200 amps output, and it still didn't penetrate. So that's not looking good for you home hobbyists that have 200 amp MIG welders or 210 in that ballpark to be using this wire in order to weld thicker plate. Well, with that said, let's go to the conclusion. So in conclusion, what do I think about this product? Well, based on all my testing, there's only really one opinion that I can form on it, and that's I wouldn't buy it. Now, you probably have the same opinion, maybe you don't, but I'll give you kind of why I wouldn't buy it. And the answer is, it does produce very clean, good-looking welds, but on 1/4-inch plate on 3/8, it cannot produce any root fusion. The actual bend strength in this test is worse than short arc MIG is, which is kind of a surprise. And the cost of this, not only is the wire more expensive, but you got to run gas with it. And so per inch, it's going to be more than MIG for 1/4-inch for no real benefit, at least on face value in the testing I've done. And not to mention, this might be this particular product, but I want to show you a couple things that I found. So I took this spool out of my machine and I got to looking at it and I realized, oh, it's cracked in there. I don't know if you can see it. So the spool's cracked and it's like, well, it's still fed, but whatever, you know, maybe that's just Amazon's delivery service for you there. And then I realized, because I just cut the wire and pulled it out of the gun. If you look here, now this didn't unravel or anything. Look at where this is pulling out of this. Somehow I got really lucky that when I finished welding, that was right at this point, but this is wrapped so poorly that it's trying to pull from like a 1/2 inch into the spool. So I probably wouldn't have made it more than 6, 7 more inches off this spool and it would have screwed up on me. So basically it's wrapped poorly, it performs poorly, and yeah, I mean, I don't know, I'll have to send an email to Blue Demon and send them some pictures of this and, you know, explain like there's issues here, you know, send me a new one or something. I'll let you guys know what I find with that if they're willing to do that. But clearly there's a lot of issues going on. And I will say, I don't believe that the 035 Dual Shield has, it's just limited to this product, because what I read for the ESAB, the 7100 and the Lincoln wires, all in 035, that all of them had root penetration problems. No matter what is what I read from a lot of people online. So I really think that this wire, maybe if you use it on 1/8 inch or up to maybe 3/16, it might be good. But again, why would you use it if it's going to cost you more, if it's not going to give you better performance? You know, and I definitely, I mean, based on what I see, this isn't something caused by Amazon. That's factory wrapped it wrong. And I mean, this is pretty much junk to me. I wasn't planning on using much more of this anyways, but I don't even think I can. Which, I don't know if this is why, but I had issues every time. So I let the thing sit, like the welder, overnight, and then I'd use it the next day to do some testing. And every time the wire would break off and it would start bird's nesting and not feed any out of the gun, okay? And I'd catch it, pull what was in the gun liner and the whip out, and then refeed a new piece. I didn't see it doing this, but, you know, this clearly has some issues, you know. So, yeah, don't recommend, which is unfortunate. My hope was that this product would give us home gamers the ability to weld, you know, 1/4-inch thick steel with really good penetration, better than MIG, without the porosity of flux core gasless, and nope, fail. So it is what it is, guys. If you got any thoughts, comments, questions, definitely leave them for me. Until next time.